Hi, my name's Harry, and over the course of this short video, myself and my colleagues aim to tell you a PCR, or Polymerase Chain Reaction.
I'm going to be giving us a quick overview of exactly what PCR is, before asking how it came about by delving into its history, looking at its humble beginnings to its widespread use today. Next, Helen and Sarah will be giving us a step-by-step analysis of what happens in PCR and what the processes are. After which, Katie will be looking at the pros and the cons of PCR, what's good, what's bad, and alternative methods which yield the same results but go about it a different way. Finally, Johnny will be looking at the real-world applications of PCR, from solving crimes to looking at genes from people from the past. Let's have a look. Before we get into the depths of PCR, let's have a look about what PCR actually is. Now, PCR is a technique used by a wide variety of geneticists and scientists who wish to study a specific section of DNA or RNA. Now, as I'm sure you're aware in science, you're studying something, you're going to need a large sample, and this was a real stumbling block for a lot of geneticists in the past, as there's no real quick, efficient way of getting your section of DNA amplified to large enough numbers in a quick enough time. However, Barry B. Mullis changed this with the PCR method. Now, we'll explain the steps and the exact process of PCR a bit better and more detailed later. But a quick overview is that DNA is put into an assay. Now, the DNA that's put into the assay contains the section that wishes to be studied. Also contained in this assay are specifically designed primers and a special heat-resistant polymerase called Taq polymerase. Now, the solution's heated, it's cooled, and it's reacted over and over and over again, roughly 25 to 35 times. And at the end of this, over a few hours, the section of DNA has been reproduced millions upon millions of times. Now, as I'm sure you're aware, this is a real game changer. And as a result, Barry B. Mullis received a Nobel Prize for Chemistry in 1993 for his work on PCR. Now, for such a groundbreaking part of science, we should have a look at what exactly were the steps leading up to how it was made. So join me as we look at the history of PCR. In 1985, PCR first appeared proper in a paper written by Saki et al. And it wasn't long until that concept was made a reality by Barry Mullis, the man credited with founding PCR. In 1988, him and the company he set it pushed it financially, pushed it commercially, and it was very, very successful. They also decided to file a patent on the Taq polymerase. Now, their push was so successful that in 1989, Science magazine named Taq polymerase Molecule of the Year. Now, as the 80s rolled out and the 90s rolled in, PCR continued to develop, with hot start PCR, which involved starting the PCR at a higher temperature, which meant the Taq polymerase was more efficient. And of course, in 1991, first high-fidelity PCR was carried out, which basically means there was less error in it. Now, in 1993, Mullis won the Nobel Prize for Chemistry for his work on PCR, which again gave a lot of push to the PCR movement. And in 1993 to today, well, PCR is still widely used. It's used in medical research, it's used in scientific research, and there's some very cool things recently it's been used in. For example, in 2007, the first human genome was fully sequenced. And in 2010, using PCR, they've managed to create a bacteria that is run by genes that are purely artificial. Now, this is not the end for PCR, and I imagine it will continue to develop. And it's been really, really interesting to look back and watch it develop. Now, I'm going to hand you over to Sarah and Helen, who will tell you about the processes behind PCR.